My name is Lauren Innes, and I'm a Senior Business Development Manager at Esri, where I provide strategic guidance to clients, partners, and regional organizations in Africa, with a particular focus on agriculture and food security. I also manage Africa GeoPortal, which is an Esri-hosted community GIS portal for anyone working in and on Africa. I have a master's degree in geology and have worked with GIS and natural resources for more than 25 years.
I'm Pauline Okel, a Senior Solution Engineer with Esri in the Middle East and Africa Regional Office, where I help our users apply GIS in solving their problems.
Climate change is a global issue, but the impact is not globally even. Although contributing the least to greenhouse gas emissions, Africa is the most vulnerable continent to climate change, to the impacts of climate change due to the large number of people relying on agriculture, fishing, or herding for their livelihood. One of the industries most exposed to the impacts of climate change is agriculture. In Africa, agriculture is the main source of income for a large part of the population. Particularly in sub-Saharan Africa, farming is mainly done by smallholder farmers and subsistence farmers who depend on rain-fed crops.
Vulnerable populations in sub-Saharan Africa are severely impacted by climate change because many of them do not know how to identify, measure, and mitigate the effects of the changing climate. These are at risk of extended drought, failed rains, or flooding. Children are also affected as more time in their formative years is dedicated.
Shows soil moisture anomalies in Africa. The orange color indicates areas where the soil is drier than historical normal. And this map puts drought particularly of Africa. This pushes more farmers and pastorals into food insecure situations and displacement as their livestock is dying and crops are failing.
As it is, demand has lain presented outputs. These include the unregulated use of fertilizers or pesticides that affect other life in the ecosystem, unethical water abstraction, which ends up starving wetland ecosystems, or even dedication of more land to production while ignoring practices that support cropland rejuvenation. This tends to bring about broader effects such as soil fertility loss in the area, eutrophication of water bodies in the surrounding ecosystem from pesticide pollution, or cases of encroachment into other biodiversity-rich ecosystems. Geographic information and derived insights could be used to correct these practices and enable vulnerable communities to shift to sustainable practices.
With GIS, we can map and analyze where staple crops like maize are currently being grown. And this helps us understand if a country which is currently relying on a certain crop will be able to produce enough of this crop into the future. Shifts in weather pattern will have an impact on what can be grown, how much of it, and where. Current agricultural lands might not be suitable for that particular crop type or land use in future.
GIS is an important tool that can be used by climate scientists in identifying which croplands have historically been severely affected by climate-related hazards, and then use spatial analysis to focus the likelihood of them being affected in future based on this trend. With this insight, agriculture analysts can use imagery and weather data to project the crop yield in their area and how much food will be available in each season. Planners combine this information with demographic data and infrastructural data, such as storage and transportation, to establish which households are not able to easily access food or mitigation. The public can also use this information
and the impact for smallholder farmers on import and export. GIS provides the tools to perform these analyses, to do the modeling, to combine existing data from different data sources, or go out and collect